Have you ever wondered how machines can recognize images? This intriguing question leads us into the thrilling world of machine learning, a fascinating realm where computers learn much like humans do through experience and understanding. Machine learning is a significant subset of the broader field of artificial intelligence, or AI as it's more commonly known. It's a discipline that equips machines with the ability to learn and improve from experience without the need for explicit programming. Essentially, it's like giving a computer its own brain, enabling it to learn, adapt, and make decisions on its own. But how does this happen? Well, the magic lies in the development of computer programs that can access data and use it to learn. These programs are designed to look for patterns, analyze them, and learn from them. They operate much like a detective sifting through clues to solve a case. Except in this instance, the clues are data, and the case is a problem that needs a solution. As these programs interact with data, they learn by identifying patterns and making associations. They evolve, becoming more accurate and efficient in their tasks. It's like learning to ride a bike. The more you practice, the better you get. The same principle applies to machine learning algorithms. The more data they are exposed to, the better they become at recognizing patterns and making accurate predictions. Machine learning is not just about recognizing patterns, though. It's also about making decisions based on those patterns. This is where the real power of machine learning comes into play. It enables computers to make decisions and predictions based on the data they've been trained on, transforming them from simple tools into intelligent assistants that can help us in myriad ways. In essence, machine learning is a game changer, revolutionizing the way we interact with technology. From recognizing your face to unlock your phone to predicting the weather, machine learning is everywhere, making our lives easier, more efficient, and more exciting. In other words, machine learning gives computers the ability to learn and make decisions from data. Now you may ask, what is deep learning and how does it relate to machine learning? Well, let's dive into the fascinating world of deep learning to answer that question. Deep learning in its simplest form is a subset of machine learning. While machine learning, as we've discussed, uses algorithms to parse data, learn from it, and make informed decisions based on what it's learned, deep learning takes this concept a step further. It uses something called artificial neural networks, which are designed to mimic the way our brains function to learn from large amounts of data. While a neural network takes in inputs, processes them in hidden layers using weights that are adjusted during training, and delivers an output, a deep neural network has many more hidden layers that are used to refine the output. This is where the deep in deep learning comes from. Deep learning models are like sponges soaking up data. They are excellent at handling large volumes of data, and the more data you feed them, the more accurate they can become. This makes them particularly useful for tackling complex tasks that require learning from vast amounts of data, such as image recognition, speech recognition, and natural language processing. One key advantage of deep learning models is their ability to recognize patterns with high accuracy. This is because they can learn and improve on their own by analyzing and comparing patterns. They don't need to be specifically programmed for each new pattern. This self-learning ability is what sets deep learning apart from other machine learning methods. Imagine this. A child learning to identify a dog doesn't need to see every breed of dog to understand what a dog is. They learn from a few examples and apply that knowledge to identify dogs they've never seen before. That's essentially what deep learning algorithms do. In summary, while all deep learning is machine learning, not all machine learning is deep learning. Deep learning drills down into the data to draw conclusions and learn from it, providing a deeper level of understanding. So, deep learning is like machine learning, but with a deeper level of understanding, hence the name. But how does a machine recognize images? Well, it's all about image processing in machine learning. This is a fascinating area of study that allows machines to interpret and understand visual data in much the same way that humans do. It's like teaching a machine to see. At the heart of this process are algorithms, which are sets of rules or instructions followed by the machine. These algorithms are designed to identify patterns and features in images. This could be anything from recognizing the face of a person, the shape of an object, or even the nuances of a handwritten text. For instance, think of a computer trying to identify a cat in an image. The algorithm would be trained to recognize certain features that define a cat. These could be the shape of the ears, the size of the eyes, or the pattern of the fur. By analyzing many images of cats, the algorithm learns to recognize these features and can then identify a cat in a new image. But how does this training happen? It's through a process called supervised learning. Here, the algorithm is fed a large number of images, each labeled with what it depicts. If the image is of a cat, it's labeled as a cat. The algorithm then uses these labels to learn how to identify features of a cat. Over time, the algorithm gets better at recognizing cats, even in images it has never seen before. However, it's important to remember that these algorithms are not perfect. They're only as good as the data they're trained on. If the training data is biased or incomplete, the algorithm might struggle to accurately recognize images. That's why it's crucial to use diverse and comprehensive data sets for training. To sum it up, image processing in machine learning is all about teaching machines to recognize patterns and features in images. This is done using algorithms which are trained on large data sets to learn how to identify specific objects or features. So, image processing in machine learning involves the use of algorithms to recognize patterns and features in images. What about deep learning? How does it process images, you might ask? Well, deep learning takes image processing to a whole new level. It's not just about recognizing the lines, shapes, and colors in an image. It's about understanding the deeper patterns and structures that are often too complex for a human eye or a traditional machine learning algorithm to discern. Imagine deep learning as a very observant detective, one that doesn't just see a face, but recognizes the minutiae of the facial features, the subtle shifts in expressions, and even the mood reflected in the eyes. It's a detective that doesn't just see a landscape, but understands the play of sunlight and shadow, the different species of trees, and the specific hues of the sky at different times of the day. Deep learning algorithms achieve this by processing raw pixel data from images. These algorithms, often designed as artificial neural networks, take in the pixel data and pass it through multiple layers of processing. Each layer of the network is responsible for identifying a specific level of detail or pattern in the image. In the first layer, the algorithm might identify simple elements like edges and color gradients. As the data passes through subsequent layers, the network identifies more complex patterns such as shapes, textures, and eventually entire objects or scenes. What's truly fascinating is the ability of these deep learning models to generalize from the patterns they've learned. Once trained on enough data, they can recognize and interpret patterns in new, unseen images, making them highly effective tools for tasks such as image recognition, image segmentation, and even generating new images. So deep learning isn't just about processing images, it's about understanding them, interpreting them, and even creating them. It's about recognizing patterns that are too intricate, too complex, and too nuanced for traditional methods. So deep learning can process images in a more advanced way, recognizing patterns that are too complex for traditional methods. It's a game changer in the world of image processing, and it's only getting better with every passing day. Let's bring all these concepts together. In the past 10 minutes, we've embarked on quite a journey, navigating the intricate landscapes of machine learning and deep learning, and their profound applications in image processing. As we draw to a close, let's briefly revisit these fascinating territories. Machine learning, as we've seen, is a subfield of artificial intelligence that enables computers to learn from and make decisions based on data. It's like a child learning to identify shapes. Given enough examples, the child eventually understands the concept. In the realm of image processing, machine learning algorithms can be trained to recognize patterns and features in images, much like our brains do. Next, we delved into the world of deep learning, a more advanced subset of machine learning. Deep learning algorithms are modeled after the human brain's neural networks, mimicking our ability to learn from experience. These algorithms are particularly adept at image processing, able to discern intricate patterns and minute differences that would be challenging for less sophisticated systems. We've also examined how machine learning and deep learning are applied in image processing. From identifying objects in an image to understanding the context of a scene, these technologies are revolutionizing the way we interact with digital images. They're the unseen heroes behind your smartphone's camera identifying faces, or the security system at the airport scanning for prohibited items. These techniques are not just powerful, they're transformative. They're reshaping industries from healthcare, where they're used for diagnosing diseases, to autonomous driving, where they're critical for recognizing traffic signs and other vehicles. So, as we conclude our exploration, remember this: the power of machine learning and deep learning in image processing lies not just in recognizing images, but in understanding them. They allow machines to see the world as we do, and perhaps in some cases even better. Understanding these concepts is the first step towards leveraging the power of machine learning and deep learning in image processing. The future of these technologies is bright and full of exciting possibilities.